In this video, I'm going to give some examples of conversions between decimal and binary. In particular, this is to prepare you for coding in Python. And in coding in Python, we have several subroutines or functions. The first function is integer binary to decimal, which in the Python code is called bin to dec int. Right? So let's see how this works. Here's a binary that I'm going to convert to a decimal. Now, since this is a binary integer, I know that this last one corresponds to 2 to the 0. So I'll write this as 1 times 2 to the 0. This one is 1 times 2 to the first. This one is 0 times 2 to the second. This one is 0 times 2 to the third. And then this is 1 times 2 to the fourth. All right, so I'm going to work my way from left to right. All right, so first I have 1. Now I know it's 1 times 16, but let me ignore that for a moment. Now let's take the first 2 bits, would be 1, 0. Now if I just had 1, 0, that would be 1 times 2 plus 0. Okay. And then the next one is if I have 1, 0, 0. Okay. Now I know this is 1 times 2 plus 0. Now I know actually this is 1 times 4 plus 0 times 2 plus 0. So what I'm going to do is I'm going to do this one times 2 plus 0. All right? And that's going to give me the same result as multiplying 1 times 2 squared plus 0 times 2 plus 0. All right, now if I add the next one, I'll have this same number. And then I have a 1 here. Now, if I want to get 1 times 2 cubed plus 0 times 2 squared plus 0 times 2 plus 1, all I need to do is multiply this times 2 plus 1. And you can work it out. This one has 1, 2, 3 2's on it, so that's 1 times 2 cubed. This 0 has 1, 2 2's on it, so it's 0 times 2 squared. This 0 has 1 2 on it, so it's 0 times 2. All right, so let me add the next one. So if I take this, if I repeat this, I have 1 times 2 plus 0 times 2 plus 0 times 2 plus 1. Now every time I multiply by 2, basically I'm shifting the binary representation over. All right, so how far did I get up to? I have a 1 there, and I have one more 1. So to get the last one, I'm just going to multiply this whole thing times 2 plus 1. All right, and that's going to give me the same result. But the difference is that instead of doing it all together in one step like this, I've done it in basically what you could call a loop. All right, at each step I've multiplied the previous times 2. And then I've added plus the last bit, plus the next bit. Right? To get this one, I've added from here to here, that's also times 2. And then I've added the plus the next bit. Okay, and then to get from here to here, I've multiplied by 2 and added the next bit. Okay? So that's the procedure for converting an integer binary to decimal. Okay, next we have decimal integer to binary. Now I'm basically going to undo the process that I did here on the top. Now the last bit here is a 1. Notice the rest of it is divisible by 2. So this 1 is the remainder that's left when I divide this number by 2. Turns out this number is 19, so let me start with 19. Okay, so the last bit, the last bit, so I'm actually going to work from right to left because I'm really undoing the left to right that I did in the previous one. So if I work from right to left, I'll say the last bit is equal to 1, which is actually the remainder when 19 is divided by 2. All right, now in this case I multiplied by 2, then I want to divide by 2, but I need to integer divide by 2. If I take a 19 integer divide by 2, note that that leaves off the remainder. Well, that's going to be the same thing as 9. Okay, and 9, if you work this out, 9 is the part here, that's multiplied by 2. This is 9 times 2 plus 1. All right, so I want the last bit of the 9 part. Now this part is the 9 part here, right? What's the last bit? There's 1. This part multiplies by 2. So 1 is the remainder when I divide 9 by 2. Okay, so then I'm going to take the second to last bit is equal to 9 divided by 2. 9 remainder 2. The remainder when 9 is divided by 2, and that's also 1. Okay, and then I'm going to shift the again by dividing by 2, and that's going to be 9 integer divided by 2. Now 9 integer divided by 2 is really the same. If you take off the remainder, that's the same as 8 divided by 2, which is equal to 4. Okay, so that's going to shift me again. All right. So next stage, I'm going to do 4 divided by 2. I'm sorry, I'll give the third to last just to finish this process. It's equal to 4 divided remainder 2. Now there's no remainder when 4 is divided by 2, so that's 0. So I'm going to shift again, and I'll take 4 integer divided by 2, and that gives me 2. And then the fourth bit, so the fourth to last, is going to be 2 remainder 2, which is still 0. And then I'm going to shift again to integer by 2, and that's equal to 1. Okay, and then the last bit is 1 integer divided by 2. So the fifth to last is going to be 1 remainder 2, and that's just 1. Okay, and then the 1 integer divided by 2 is 0. Okay, so if you pick up these bits, 1, 0, 0, 1 is here, 1. And you can read these notes all together. I realize that it's kind of hard to see it from here. Okay, and these are the bits in reverse order, from lowest to highest. Those are the bits from lowest to highest. So to get from highest to lowest, you have to reverse the order. Okay, so you see here we also have a loop. We're looping through and continually dividing. So, and I hope you can see that this is undoing the previous one. We continually take the remainder as it shows here. Take the remainder here, and then integer divide. Take the remainder again, integer divide. Remainder again, integer divide. And this exactly undoes the steps in the binary to decimal conversion. Okay, so I'll make the next 2 conversions on the next video.